Okay, so whether you're done or not done or almost done, I'm going to get started. So just so we can compare notes. So Amazon.com is one of the largest internet-based retailers in the world. The company offers Prime membership for a fee. A recent report states that 46% of US households have a Prime account or Prime membership. Penelope wants to know if this proportion is different for her hometown, her large hometown. So it's like Fresno. Okay. She selects a random sample of 80 households from her hometown and finds that 43 out of the 80 have a Prime membership. So her P hat is 43 out of 80. Okay. So 0.538, which is bigger than the US, right? We're trying to see if it's significantly bigger so that we can say, no, 4.6 is actually wrong. We're trying to say 0.46 is wrong. That's the claim. Okay. So, is there convincing evidence that the proportion of households in this town differs from the claim in the report? Convincing evidence. That means test. Okay. So, population parameter P equals the true proportion of US households that have an Amazon Prime account. The hypothesis, the null hypothesis is the claim, 0.46. We're trying to see if this town differs from it. So again, it's going to be not equal to. Significance level is 5% because they didn't give us a significance level. Okay. Formula, same one we used yesterday. Conditions, same ones we used yesterday. Okay. Calculations. It's a two-tailed test. Two-tailed test because it's not equal to. So we're going to have greater than and less than. Okay. That's the difference between a two-tailed test and a one-tailed test. The distance here, let's see if I have it, is 0.078. That's the distance here. So I found the exact same distance, but on the other side, and that was this number here. Okay. Mm-hmm. Say it again. Where I just explained. This guy right here is our P hat, our sample proportion. Okay. Since it's a two-tailed test, we have to check both sides. So 538 is from the proportion. And then I have to figure out something over here too. Well, the distance from here is 0.078. So the same distance, but in the opposite direction, would be 0.382. You only have to do that when it's not equal to. Example number 1 that we did a few days ago, that one was a one-tail test. We only shaded one side because our hypothesis was less than. Okay, so just depends on what your alternative hypothesis is. All right. So z-score 1.39 and negative 1.39. Each one has 0.0823, so the p-value is both shaded areas, which is right here. Uh-huh. That's fine. Yeah, that's fine. Okay. Now it's conclusion time. Do we reject or fail to reject? Well, first thing we're going to do is we're going to compare p-value with alpha level. Okay. So since our p-value is bigger than our alpha, p-value is too big, we fail to reject the null hypothesis. So I fail to reject the claim. I can't reject it. I can't say it's wrong. Is it right? I don't know. But I just can't say it's wrong. So because we failed to reject, therefore we lack or do not have sufficient evidence to suggest that the true proportion of all US households who have an Amazon Prime account differs from the claim, which is 0.46. Okay, this part right here is the alternative hypothesis. Okay, it all stems from the p-value. If the p-value is bigger than alpha, you fail to reject and you don't have enough evidence. If the p-value is smaller, like if this guy was smaller than 5%, then we would reject and we would have enough evidence. Okay, then we could say they're liars. I have enough evidence to say, nope, the claim is wrong. Okay. So we don't have enough evidence. There is not convincing evidence to say that it differs. This town differs from the US average or US percentage, right? Even though, look at this town's proportion and this, it's different, but it's not enough to be significant. Okay, it's just different. All right. And then question B says, what would your conclusion, so just the conclusion, what would your conclusion be or would it change if your significance level was 1%? So if our significance level was 1%, would our conclusion change? No, yeah. Our conclusion would not change. Would the blue stuff change to red? Would this change to less than? And therefore, no, it would not. Because our p-value is too big still. Even 10%, even if I change the significance level to 10%, it's still too big. So it would not change for 1% or for 10% because my p-value is too big. So you'd explain in words, just explain in numbers, however you explain that. Nope. Conclusion would not change at 1% or 10% significance level because the p-value is just too big. Okay? P-value has to be smaller than significance level. Okay. Okay, one more thing I want to show you before I let you guys work. The calculator. Calculator will do the calculations for you, just like it did with your intervals, right? So get your calculators handy. I'll show you how to do that. So we're going to do these calculations using the calculator functions. So intervals or test, doesn't matter which one, you're going to go to the same spot. You're going to go to stat, scroll to test. That's where our list of intervals and tests are, right? We're not doing intervals this chapter. That was last chapter. So we're looking for the things that say test, right? So we have 1 and 2 are test, 3, 4, 5, 6 are test. So we have to figure out which tests we want. Well, this is a proportions, right? So we want it to say proportions. So that leaves 5 and 6. We only had one sample from the one town, right? So it's one proportion z-test, which is number 5. Okay. P sub 0 is another word for the claim. Sometimes they put sub 0, sometimes they don't put sub 0. It's the claim. The claim was 0.46. N. N is the total in our sample, which was 80. 80 people, right? X is the top number. What was the top number above 80? 43, right? And then the next one is, which one did you choose as your alternative hypothesis? Not equal to, less than, greater than. We chose not equal to, right? Okay. It gives you two options. It says calculate or draw. It doesn't matter. It doesn't matter. Calculate gives you more data, more stuff. Draw is kind of cool because it draws the same picture you guys drew. I'll show you both. I'll show you calculate first. Calculate shows you z-score, right? It shows you a z-score. It shows you right underneath is the p-value. Right underneath the z-score is the p-value. Right underneath that is your sample proportion. Right underneath that is n. So it shows you z-score, p-value, p-hat, which is what we knew. With the last two we knew at the beginning, but it shows you that. That's calculate. Now, draw, I'll show you what that one is. Same numbers, same values. I'm going to show you what draw is. It's going to look very, very familiar. That's the picture that you drew on yours for calculations. Right? It's two-sided, two-shaded. It only gives you 2 bits of information, but it's usually the stuff that we need. Z-score at the bottom, p-value at the bottom. Those are the 2 that we need to calculate, right? So that's either one. It doesn't matter which one. Either calculate or draw. Okay? That'll give you your calculations. Nothing changes though. You still do the same exact stuff you did before, but this helps speed up the calculations a little bit. It does the z-score faster and the p-value faster. You don't need it, right? You can just use your calculator the way you regularly do and then use your tables. That works too, but this maybe goes a little faster, especially for multiple choice questions when you're just trying to calculate p-value really quickly or z-score really quickly. Okay. All right. Okay. So